All right, this is going to be a very thorough explanation of how you make the unit circle. So first of all, we're going to go through and label the degrees and the radians, and then we'll work on the coordinates. Okay, so we'll start from easiest to hardest. So the easiest thing is degrees. We always start right here. Here's our 0 degrees. This is our positive x-axis. See, this is our x-axis. This is our y-axis. We always start in our positive x direction. That's our 0 degrees. And then we go around counterclockwise. So we know all the way around a circle is 360. So if I go all the way around, I get 360 degrees. So here I could say this is 0. I could say it's 360. I could go around again and say it's 720, etc. I could keep turning and turning and turning and keep going around and adding more and more values out here. All right. So notice, though, if we're just doing the 3, we'll just go around one time, okay? We're not going to worry about going around multiple times. We're just going to go around once. So when I go around 360, notice it's broken into 4 pieces. So what's 360 divided by 4? 360 divided by 4 is 90. That means each one of these is 90 degrees. So you all knew that this is a 90-degree angle from here to here, but I just want to say, well, how do we know that's 90 degrees? We know because there's 1, 2, 3, 4 pieces. Okay, so then add another 90 to that, we get 180. Add another 90 to that, we get 270 degrees. Okay, notice there's these little dots halfway in between. So I'm going to go ahead and cut that in half. All right, I just cut 90 in half. So what's half of 90? 45. So this is 45 degrees. All right, so each one of these pieces is going to be 45 degrees. So if I put in this line here, 45 plus 45 is 90, plus another 45, 90 plus another 45, well, that's 135. So this is 135. So notice I don't have it memorized. I'm terrible at memorizing things. I'm much better at logically thinking things out and then doing my little arithmetic. Okay, so here, again, I'm at 180. I'm going to add another 45. So 180 plus 45, 5, 8 plus 4, that's 12. So that's 225. See, I do not have these memorized. I actually just do the addition. And then I got to add another 45 here. So 270 plus 45, that would be 315. And then just to check to make sure I'm doing okay, 315 plus 45, does that get me to 360? Yes. All right, I did it right. So those are my degrees. Radians, I find, are actually a lot easier. One thing you got to know, though, is that it is 2 pi radians all the way around. Okay, so if I'm doing radians, I'll do them in a different color. My radians all the way around is 2 pi radians. And I should probably I'll put up the video where we explain what is a radian to make sure that everybody is good with that. But just to remind you, what is a radian? If you take the radius, this length, and you wrap it around the circle, if you take this length right here, the radius, okay, so if I take from here to here, and I take that length and I wrap it around, so I go 1, then I put it there, and I do it again, and I wrap it around 2, and I wrap that around again. This is kind of funky hard to do. 3. So it's 3 times and a little bit more. So it wraps around 3 times and a little bit more. 3.1415, blah, blah, blah. It wraps around pi times to get to here, and another pi times to get to here. So if you take that length of the radius and you wrap it around the circle, it takes 2 pi, more than 6, because pi is around 3. 2 times 3 is 6. It takes more than 6 of those to get around. It takes exactly 2 pi to get around. Okay, so now all the way around the circle is 2 pi radians. So now notice we have divided from here to here. That's dividing it in half. 2 pi divided in half, that makes this pi radians. And now notice I have 1, 2, 3, 4. I have 4 parts right here. So pi has been, I should put 0 radians, 2 pi radians. Sorry, just caught myself. Okay, so from here to here is pi radians, and it's been divided into 4 pieces. So that means this is pi divided into 4. It's 1/4 of pi radians. So that means this is 2/4 of pi. This is 3/4 of pi. That makes this 4/4 of pi. This is 5/4, 6/4, 7/4, and 8/4. And when we reduce these, 8/4 is equal, 8 divided by 4 is 2. 2/4 is the same as 1/2, so pi over 2. 3/4 can't reduce it. 4/4, 4 divided by 4 is 1, that's why it just equals pi. 5/4 can't reduce. 6/4, I can reduce that. That's 3 pi over 2. 7/4, I can't reduce that. So here's my radians. And notice I didn't memorize anything except that it's 2 pi radians all the way around. That's the only thing I had memorized. And then here's my radians. So some of you are probably great at memorizing, and you can just memorize this and write them down real fast. Me, even though I've been doing this for years, I still don't have them memorized because I have a horrible memory. Okay, so there's our degrees and our radians. Now we're ready to do the coordinates. Oh no, sorry, I don't want to do the coordinates yet. Let's do the other circle. Those are my 45 degrees. I don't like putting them all on the same circle. The next one I'm going to do is going to be the 30-degree increments. Okay, so this one, we also like to divide our unit circle into 30-degree increments. So right here, this is 30 degrees, 60 degrees, 90 degrees. Okay, we knew from before, this is 0, this is 90, and I've divided it into 3 pieces. So 90 divided by 3 is, oops, I'm off the charts there, is 30. So this is 30 degrees. I'm adding 30 degrees each time. So 30 plus another 30 is 60, plus another 30 is 90, plus another 30 is 120, plus another 30 is 150, plus another 30 is 180, we're looking good, plus another 30 is 210, plus another 30 is 240, plus another 30 is 270, plus another 30 is 300, plus another 30 is 330. Okay, again, I do not have them memorized. All I know is that I need to add 30 degrees each time because this is each 1/3 of 90. So that's how I'm doing that. Okay, the radians, even easier. So from here to here, I know that's pi. That's my pi. How many pieces did I cut it into? 1, 2, 3, 4, 5, 6. It's in 6 pieces. So that means the first piece is 1/6. This is 2/6. This is 3/6. This is 4/6. This is 5/6. This is 6/6. This is 7/6. This is 8/6. This is 9/6. 10/6. 11/6. 12/6. And then I can reduce my fractions. 12 divided by 6 is 2. There's my 2 pi. Can't reduce. That reduces. I can divide both of those by 2, and I get pi over 3. 3/6, that's the same as 1/2. So pi over 2. 4/6, divide by 2, 2 pi over 3. Can't reduce. 6 over 6, that's just 1. That gives us the pi. 7/6, can't reduce. 8/6, I can reduce that. 9/6, I can reduce that. 10/6, I can reduce that. 11/6, can't reduce. That's how I get my radians. All right, so now we got to do our coordinates. So this is a big mess, so I'm going to actually put the coordinates on another circle, but I'm going to get started on here. So to get the coordinates, I want to know if this is my x, and this is my y, and I know that my radius is 1. I want to know, how do I get to this point? I'm going to have to go over, and I'm going to have to go up. And notice that makes a right triangle. So what have I got here in my right triangle? This is a 30-degree angle, right? Because I'm moving 30 degrees. So if this is 30, this is 90, this has got to be 60. So I have a 30, 60, 90 triangle. Okay, look at the next triangle. Bam, right here. This angle is 60, because from here up to here is 60 degrees. So this is 60. This is 90, and this is 30. Hey, wait a minute. This is the same triangle. This radius and this radius, of course, are the same. So this is the same triangle. So if I can just figure out what are the side lengths of this triangle, I can then say long side, short side for my x and my y. And for this one, short side, long side. That gets me my x and my y. Okay, this one's easy because this distance is just 1, so this is going to be 0, 1. And then to get here, it's short, long. To get here, it's long, short. This one is just negative 1, 0. This one is long, negative, long, negative, short. I'm just going to say long, short. Long, short, short, long. This would be 0, negative 1. This is short, long, long, short. So what are the long pieces and the short pieces of a 30, 60, 90? Okay, let's say you've forgotten. It's not in the formula packet. You can't look it up. You're taking a test. Where the heck did it come from? So it comes from, it actually comes from an equilateral triangle. So I'm going to show you where this came from, and then we'll put it back on for the coordinates. So where does a 30, 60, 90 triangle come from? It actually comes from if you start with a regular triangle, an equilateral triangle, if all three sides are the same length, okay, I'm going to say they all have a length of 1, then all the angles have got to be the same. So we know from geometry they all have to add up to 360. So 360 divided by 3 gives me 60 degrees each. I'm sorry, 360. Why am I saying 360? Somebody stop me. 180. Sum of the interior angles of triangles, 180. 180 divided by 3 is 60. So this is 60 degrees. Okay, now where am I going to get my 30-degree angle from? Because I'm trying to figure out the shortcut for the 30, 60, 90. Well, if I take a 60-degree angle, all of these are 60 degrees, and I cut it in half, now I have a 30-degree angle. Okay, so this is 1. I said my hypotenuse is 1, just like on my unit circle. I now cut this side in half. So what's this? It's now 1/2. All right, now I got to get this side. Okay, so let me put this separately now. So I've got this right triangle right here. This is my 30 degrees. This is my 60 degrees. This is 1, and this is 1/2. Okay, how do I get that? Pythagorean Theorem. Okay, so I'm going to call that A. A squared plus 1/2 squared is equal to 1 squared. All right, A squared plus 1/2 times 1/2 is 1/4. 1 squared is 1. Subtract 1/4 from both sides. A squared is equal to 1 minus 1/4. How do we do that? Make 1 a 4/4. So 4/4 minus 1/4 is equal to 3/4. So A squared is equal to 3/4. Square root both sides. I get A is equal to square root of 3. I don't know the square root of 3, so I'll just leave it. But I do know the square root of 4. Square root of 4 is just 2. So this side, instead of calling it A, I can call it square root of 3/2. So this is how we get the sides of our 30, 60, 90 triangle. When you were in geometry, you were asked to memorize a formula. The formula looked like this. It said if this is, the short side is x, this is twice as long, and then the long leg is whatever the short side is times the square root of 3. You were asked to memorize that. Well, now I've just proven to you where it came from. All right, so if our long side is 1, half of that would be 1/2, and then 1/2 times the square root of 3 is equal to square root of 3/2. Okay, so on our unit circle, our short leg is going to be 1/2, our long leg is square root of 3/2, the hypotenuse is 1. So back to putting on our coordinates. Instead of putting it on this big messy one, I'm going to put it on a nice clean one. This is my 30, 60, 90s. Okay, so this point right here, to get to that point, I go long leg, short leg. Long leg, square root of 3/2. Short leg, 1/2. The next one, to get to here, how do I get there? I have to go short and then long. So this would be, the short leg is 1/2, the long leg is square root of 3/2. Okay, these ones, the vertical and the horizontal, should be easy. That's 1, 0. This is 0, 1. Okay, this one, if I draw in my little triangle, it's short, but I'm going negative now. So negative 1/2, and then long. So positive square root of 3/2. Okay, and then this one, to get to here, I have to go long in the negative direction, and then up, short the short leg. Okay, and over here, negative 1, 0, and then over and down, so long and short. And I'm going down, so it's got to be negative. Okay, to get here, negative short, negative long. So negative short, negative long. Okay, short, long. This one, it's just that one, so 0, negative 1. To get here, to get to this point, I got to go short leg in the positive direction, and then long leg in the negative direction. And here, I got to go positive direction, long leg, short leg. So long leg, and then short leg in the negative direction. And there's all my coordinates. Okay, so notice I didn't do any memorization. All I did is I just took my little 30, 60, 90 triangle and just figured out where's the long, where's the short, where's the long and the short. Is it the X or the Y? And then I made sure that if I'm going to the right, it's positive. If I'm going to the left, it's negative. If I'm going up, the Y is positive. If I'm going down, the Y is negative. And there it is. No memorization needed. All right, the 45, 45, 90. Hopefully that one's a little bit easier. If I have a 45, 45, 90, this angle and this angle are both the same. So and also these two side lengths are the same. And remember, we know our hypotenuse is 1. So here, if I do my Pythagorean theorem, x squared plus x squared is equal to 1 squared. X squared plus x squared, well, I have 2x squareds. 1 squared is 1. I'm trying to get the x by itself, so divide by 2. X squared is equal to 1/2. And then square root both sides. Okay, that's an exponent, sorry, kind of hard to tell. So I get x is equal to the square root of 1/2. But I can separate these. The square root of 1 is just 1. Square root of 2 is the square root of 2. IB doesn't care, but some people do. You can rationalize the denominator by multiplying both the numerator and the denominator by the square root of 2, and then you get the square root of 2 over 2. So it's fine to leave it like this, or you can rationalize the denominator and put it like that. So those are our side lengths. This is 1 over the square root of 2, and this is also 1 over the square root of 2. So when we put on our coordinates on our unit circle here, this point's easy. That's just 1, 0. To get here, I have to go over and up. But notice this is a 45, 45, 90 triangle. These two are the same. These two are the same. So it's just that 1 over the square root of 2, or if you prefer, you can use square root of 2 over 2. So 1 over the square root of 2, 1 over the square root of 2. And they're both positive. Okay, this again, of course, is 0, 1. Now to go here, I got to go negative, positive. So negative, positive. And then this is negative 1, 0. To get here, I got to go negative x and negative y. And 0, negative 1. And here, to get to this point, I got to go positive and then negative. So positive and negative. And that's it. There's our coordinates. All right, I hope that helped.